Okay, I want to show something I think is pretty cool. I just came up with a somewhat of a interesting little invention, I think. And it actually works. I've been doing some testing. That's why the wires are hanging everywhere. And it's kind of scary looking. But let me show you what I've created. This here is an RV. If you don't know what you're looking at, this is a monitoring system that monitors the black and the gray tank. Black tank, of course, where all the poo goes. Gray tank is where the shower and sink water goes. And of course, that's the black tank is a gray tank. What can happen sometimes is, say for instance, your gray tank is full except to the red light, but you don't really don't know it, and you got the valve closed. And then someone turns on the washing machine, and all that water goes in. It's already full, and ain't got nowhere to go, and it overflows. Comes out the shower and goes all over the floor, and you have a flood. That's happened to us almost once. I caught it early, just before the water started coming onto the floor, and got it stopped. But I got to thinking, well, what could I do to prevent that? So what we have happening here is, as the tanks fill up, you get to 3/4 and you get to full, the light comes on. So I got to thinking, well, if that red light comes on, why can't I make that red light also trigger an alarm? So I got to taking things apart, looking at it, but what I ran into was nothing but a circuit board, not no type of simple switch or anything. So then I got to thinking, well, the LED light that comes on, voltage gets applied to it, even though it's a very low voltage. So I got to thinking, well, there's got to be some kind of device that can detect that and then trip a relay, and the relay trip an alarm. So I talked to a fellow who knows electronics, and he's told me, I told him what I was trying to accomplish, and he said what I need is something called a voltage comparator module, and that's what that little device is. So this little dude is very sensitive, cool little device, only like $11, I think. So what it does, these two wires here are coming off the positive and negative side of the diode, being the LED light. And then we have a power coming in off the house, house batteries, positive and negative, that powers this board that will also power this relay. So as soon as that red light comes on, this device, which is very sensitive, it notices the voltage change between the positive and negative on that LED. It says, hey, the LED has lit up. Let's trip a relay. When it trips the relay, it in turn operates this buzzer. Put some tape on it because it's extremely loud. So now I'm going to turn on some water to see if it works here. So, alright, so that is, water's on there. Turn on some more water. Just wait for it. Gotta wait for the red light to come on here any day now. Let's wait. There it goes. So when that goes off, I know there's a flood about to happen. Hang on. God, that thing's noisy. Okay, I have to unplug the power to it because it's very loud. But anyway, when that alarm goes off, I know to go outside and pull the dump valve, get the water out, and we have no flooding. So at least I know it will work. Now I got to tidy up all my wires, do some soldering, and tape stuff up because everything's very loose and a mess. I just wanted to test the ideal first to see that it works, and it does work. So I'll make another video later of the finished product. Well, as you can see, I got the board back out, and where I can show you things a little bit closer what we did. Of course, you can see here, you can follow the traces on the LED. That's the top LED right there when the tanks are full, and that's the negative side and the positive side. All the LEDs use the same positive. You can see the trace. They're all tied in. It's the negative side that gets the voltage change, that actually turns the lights on and off. So that's what we've tapped into and fed the voltage comparator, which would in turn trips the relay, which in turn sets off the buzzer. So that's what works great. But I'm kind of kind of limited on tools. Actually, we're down here at Kissimmee, Florida. We're right in the middle of the coronavirus thing that's going on, and so I'm kind of bored. Can't go to Disney. Can't do a whole lot of stuff. So I'm finding projects to do because I'd rather be here as to be back home in Kentucky in the cold rain. So I'm just making do with what tools I have. And Larry let me borrow this really cool pair of strippers. Never seen a pair of strippers this nice. Made by, what's the name of this company? It's called Strip Master. So I've already got a pair of these on my Amazon wish list because that is an incredible pair of strippers. About 40 bucks. Man, are they nice. Especially when you're stripping these small wires, because you don't lose any strands. You can strip these itty bitty wires because this thing is so sharp, it'll pull it, separate it, and you won't lose any strands of wire like you will sometimes with your cheaper strippers. What else I was going to mention to you? I found out this board is actually made by a company called LevelGuardProducts.com. So one of my concerns was, and I was thinking this through my head, is the fact that this has a momentary switch originally here. You got this momentary switch. So I got to thinking, well, maybe there's a purpose in that momentary switch, because I knew for this contraption to work, this board would have to be powered all the time. So I'd have to change this momentary switch to a rocker switch. So I called the manufacturer and they said that's fine, I can do that. The reason they put the momentary switch on there is in some applications this board may be mounted in a bedroom somewhere and you wouldn't want those bright LEDs glowing all the time. So got that part figured out and I got a switch on the way. Also, while I was talking to him, I was trying to get a better understanding of how this works. I should probably go outside and show you the sensors on the tank. Let's do that. Okay, so here you go. You can see this is my black tank. This is on a 38J Winnebago, and you can see these little pads. They just stick on there. There's no holes or anything drilled into the tank. Nothing touching the liquid on the back side. So it's kind of a mystery to me. How do these actually work? So actually, what they're doing, they produce what they call it, like a small electric field. So it detects, and it's something called let me think of that word. Something called a dielectric constraint. And so when liquid gets on the back side of that plastic, bottom line, it senses that, and it works as the liquid comes up. Then these sensors notice there's liquid on the back side, and it changes the voltage, and the LEDs come on. So pretty cool technology. You know, I guess back in the day, I did some searching on that particular board. It looks like, from what I can tell, it's been used from 2001 to at least 2006, and maybe more than that. But I just did a quick Google search on that circuit board, and I've seen a lot of Winnebago manuals popped up with those years on them. So that kind of gives you an idea how that works. Okay, back inside, I just thought I'd show you. There's the components I ordered to put this contraption together, and I'll put them in the link in the video. But just took 3 items: the comparator module, some of the little piezo noise makers, and then the switches here. Of course, you can get, it's amazing. I just needed one. Of course, I can get for $5.99. I can get 12, so I'll have more for other projects. So those little components, and they're not very expensive at all. Okay, back outside. I want to explain something. Of course, you might say, okay, it makes sense putting an alarm on the gray tank, but why an alarm on the black tank? The reason I want an alarm on the black tank is because because I got this semi-flush on here, which works pretty good, and I like to hook my hose up to it, but I also like to fill it completely full and then dump it, do it completely full. Do that 3 times. But it's a kind of a pain because you got to sit and babysit the lights, make sure when to wait, walk in there. Is the top light on yet? And I know me, I'm easily distracted. One of these days I'm going to get a phone call, I'm going to get distracted, the tank's going to get full, sewage is going to be shooting out the roof through the vent. So I thought, well, this would be a cool way with this now. I can hook this up, have it closed, let it fill up. As it's filling up, I can be tinkering outside, I can be inside doing whatever. When the alarm goes off, I know it's time to come out here, pull the valve. After it dumps all out, shut the valve back. When I hear the alarm go off again, come out, pull it again. So that's my plan anyway, so I think it's going to work out for me. Okay, I guess it should maybe explain the wiring on this thing, because these little comparative boards are very handy for a lot of different applications. This might help other people, because this is my power coming in, and of course now I've got the wires in there. I'm trying to see which one's positive or negative. It's kind of hard to tell now. Okay, I have to pull the wires back a little bit to find what was what. Alright, so anyways, so we've got our power coming in, and this being the negative, that being the positive, this being our sensor on this side. That's the negative side of the LED, that's the positive side of the LED. It's looking for the difference. And of course I've got my you can see I've got my buzzer tied into the positive side on this wire. Then I got a jumper going off the negative into the relay. In this relay you got two sides. You can either, because it's the common, you got normally open, normally closed. So I've got it jumped over here to the normally open. So when the LED comes on, the comparator senses it, and it closes the relay, and voila, I got a buzzer. It goes off. And then if needed, this is adjustable from 0 to 12 volts. Actually, I didn't have to adjust it at all. As soon as I hooked it up, it was working. So I haven't had need to adjust the rheostat, I think it's called. So anyways, that's kind of how that works. Okay, got everything back together, and so now you can see I got rid of the momentary switch and put in a rocker switch. So I just flip it and it stays on. And right now I'm filling up the black tank because I got the alarm set on both the black and the gray. So the black tank is filling up. As soon as that red light starts to flicker, it'll probably take another 5-10 minutes. It takes a while. And then I'll do this process 2 or 3 times until everything runs clear and clean. Okay, showing you an example of how I do this. Now it works out good for me because I got this the black holding tank flush. I got the hose hooked up to it. I got it running right now, so it's filling up the tank. We'll go inside. Okay, I'm inside. Flip on my light, and this will be slowly going up. When it hits the red light, it'll start buzzing. Instead of me standing here waiting and watching and wasting my time with that, I can be outside cleaning the windshield or doing something productive. When I hear it start beeping, I'll go dump it again. Okay, good example. So I'm out here cleaning the windshield off, and I can hear that beeper starting to beep. So I'll show you. Sounds like Morse code at first. Once it goes pretty solid, I know it's time to go dump. Let's go dump and see how clean it is. Alrighty, let's go see what she looks like. It looks pretty good. That's the 4th time I've done it. Let it fill and flush, fill and flush. I think we're good to go. Get all that cleaned out. Be ready for the next trip. Easy peasy. Make yours today.